Back to another exciting episode of Math 370. Let's talk about section 2.3. So we're still on this kick of talking about functions. So now we're going to look at the properties of them. So let's go ahead and define this right here, even and odd. So we have even and odd numbers, but we also have even and odd functions. So what the heck does that even mean? So a function is even if f of negative x is equal to f of x. So you would get the same result if you plugged in like -2 and +2, or -3 and +3. Now a function is odd if f of negative x is equal to negative f of x. So if you plugged in a negative number, it would give you the opposite of when you plugged in the positive. Okay, so example 1. Determine algebraically whether or not the function is odd, or even, odd, or neither, because it's not guaranteed to be one or the other. There are a lot of functions out there that are not even and they're not odd. Okay, so again, it's kind of like the symmetry stuff. You can kind of cheat a little bit. Basically, if it's even, is if all the powers on the x's are even, because the even powers get the negatives to cancel out, and it gives you right back to where you started. But if it switches in sign, that means that the exponents were all odd, because then it would just flip it. Okay, so but sometimes it's a little bit interesting. So algebraically, like if you just didn't understand what the heck I meant by all that stuff, algebraically just plug in a negative x and see what happens. Okay, so if you plugged in the negative x, it would look like that. So then you would have negative x on top over x squared minus 1. Well, if you compare it to the original, it is the exact opposite. Well, if it comes out as the exact opposite, that means the function is odd. Okay, for part B, plugged in a negative x. That would be x squared minus 3x. So you didn't end up with the exact same thing, and you did not end up with the exact opposite. So if you don't get the exact same thing or its opposite, then that is neither. So let's look at what we have though. So your exponents, you had one exponent that was even and then another one that was odd. So if it's a mixture of odd and even exponents, where it's not in like in a fraction like this, that's a big ol' neither. But if you notice that all of your exponents are even, then that would make it an even function. Because if you plugged in a negative here and here, it's going to cancel out. Okay, now this one, if you plugged in negative x, you do not get the exact same thing, nor its opposite, so that's neither. And then for this one, you have the cube root of negative x. Well, you can have a negative inside the cube root and it would simplify, it just pulls out. So you get the opposite. So that makes the function odd. So for polynomials, you can look for the odd and even exponents. If they're not a polynomial, just plug in negative x and see what happens. Okay, moving on. Let's define the average rate of change. From x equals a to x equals b, the average rate of change is f of b minus f of a all over b minus a. That is the formula for it. And we just saw in another section what this actually was. It's a difference quotient, but this one was a basic one. And it was basic because that was just the slope. So now they've just defined it as the average rate of change. So example 2, find the average rate of change of this function from x equals -1 to 1. So you just got to follow out what the formula says. So f of, and then when it lists this out from where to where, the smaller number is always a, the bigger one is always b. So f of 1 minus f of -1 all over 1 minus -1. Okay, so if you plugged in the 1 into the function, you get 2. If you plug in the -1 into the function, you get 6. And then your denominator is 2. So simplify it down to -2. Okay, so let's find the ARC. That's just the average rate of change, not American River College. So find the average rate of change, or the ARC, of that function from 0 to 8. So it doesn't matter what the function is, you're always going to follow that formula for it. So we have to figure out f of 8 minus f of 0 all over 8 minus 0. So f of 8, that'd be 8/10 minus f of 0 is 0 all over 8. So 8/10 minus 8. And when you divide by 8, it's the same thing as multiplying by 1 over 8. So you get 1/10. So I did it a little bit different in the notes, mainly is because I simplified the fraction. You just want to make sure your answer is simplified at the end. If you don't simplify the fractions in the middle, that's okay. All right, let's go ahead and stop the video here, and we'll continue on in the next video.